So yeah, let's learn about caching, right? Let me write the topic, which is caching. Caching is a very interesting topic. What are types of caching and where we can store our cache, right? So let's learn about just caching. So what is the caching? Caching is the process of storing frequently accessed data in a temporary storage location called a cache, right? So we store our data temporarily in some low storage location, right? This is called cache, which is called cache, right? In order to quickly retrieve it without the need to query the original data source, right? So let's suppose that we have our this is, let's suppose, Redis, right? Redis is also a type of cache storage management database. We have our actual DB. So whenever we have a request from user to our server, what we do? We first check our Redis. Does it have the data? If it doesn't, it's a cache miss, right? Whenever cache miss happens, we try to hit the DB, then we store that database in our Redis and then in the key value pair, so it's easy to query. It's easier to read. It's the read speed is faster compared to other DBs. So we use key value pair or type of database. Then when after reading from the database, it stores the data in the Redis and also respond back to the user. Now on the second time when user hits the Redis and hits our server with any request of same data, it will be a cache hit because we got the data in Redis, so it will return it from here. The time difference is like from request going from year to year, it took around, let's suppose, 200 milliseconds. Okay, not 200 actually, it took around 500 milliseconds, right? But when it will return it from Redis itself, it will be a very quick response, right? It won't need to go to the database and query the database. It will be around 10 ms, 10 millisecond or 2 millisecond. It can reduce significantly. When you will actually implement it, you will know how it works. So there are several caching strategies. So there are several caching strategies. First is refresh ahead. Second is what? Write behind. Third is write through. Fourth is what? Cache aside. Okay. That's all. Also, you can have the cache in several places. Examples. The places to store cache. Places to store cache. What are the places to store cache? First is client caching, right? Client caching. It means on front end or backend server, wherever the client resides. CDN caching. Okay. CDN also have place for caching. So CDN, content delivery network. We can store our items there. Web server caching. This can be done using Redis for faster response time. Our database caching. We can have a cache in front of database or in database. We can do that. Okay. Fifth is what? Application caching. If you are creating an application using Electron or Flutter, so you can, or let's suppose React Native, then you can cache there as well. That can also be done. So these are the places to store cache. Please ignore my handwriting or make fun of me. I will try to improve it. You can also provide some suggestion how to improve it. I'm practicing, but I'm not sure. Like on book it's good, but here I'm not sure why it's like that. Okay, so that's all about caching. Now let's learn about this refresh ahead and sort of strategies. What is strategies means what? So what is a refresh ahead strategy? Let's learn about this first. Okay, let's go one by one. Refresh, then write behind. This is behind, not this. Write through, cache aside, right? So first let's learn about refresh ahead. Okay, so what is refresh ahead? You can configure the cache to automatically refresh any recently accessed cache entry prior to its expiration. So what we can do, let's suppose that we have stored a cache. If user U1 has requested something from our server, let's see, this is our server. This is our cache store. Okay, this is our server. And it's a cache miss, then it will go to server and respond back, right? And what will happen in this process, it will store that k1 value and v1 value in the cache. Now what we will do, we will try to store this k1 and v1, right? But we need to refresh it. So what we can do, we can configure this cache to automatically refresh any recently accessed cache. So there will be multiple, right? So we can use FIFO, first in first out, or LIFO, which is last in first out method, a strategy to make sure that we can refresh those items, right? So recently accessed means k1 v1 will be recently accessed, and kn and vn will be last accessed, right? So this recently accessed, we can go to the database and make sure that these key value pairs are updated, right? If there is any change in the database, then we can make sure to refresh this. So it will make sure that our user gets updated data. A refresh ahead can result in reduced latency after doing, as we are automating this process. So it will of course reduce the latency. It will reduce latency. Okay, latency will be reduced significantly. Versus read through, if the cache can accurately predict which items are likely to be needed in the future. Also, it can improve read, but that depends if we can have some prediction system which predicts what user will try to access, right? So what we will do, we will get that value from our server and store it prior to the user request in our cache. And now what are disadvantages of RA, refresh ahead cache? So what are disadvantages? Not accurately predicting which items are likely to be needed in the future can result in reduced performance without refresh ahead. So of course we cannot predict what items user will, if we cannot predict what items user will be in need in future, so of course there will be latency in performance, the response time will become slower. So that's one disadvantage. Prediction logic is hero. So it's a hero actually. If it's correct, if we are able to predict what user will be demanding for the next request, then it's a go thing. Just go for it. Go for refresher. Now let's learn about write behind. What is write behind, right? Let me just go down. Write behind. Okay, write behind cache. What is the write behind cache? In write behind cache, the application does the following, which is add update entry cache. So it will add or update entry cache. It will asynchronously write entry to the data store, improving write performance. So write behind is basically for improving write performance. So that's about it. So write behind cache, what it will do, it will add an update entry in cache. It will asynchronously write entry to the data store, improving the write performance. What are disadvantages of write behind? So this will also follow a type of LIFO or FIFO depending on the write cache logic that you have wrote. It will try to write entry to the data store and improving the write performance, right? Now what are disadvantages of WB cache? What are disadvantages? The first is there could be a data loss if the cache goes down prior to its content hitting the data store. If the cache goes down, right? Okay, so what we are doing here now, write behind cache means if user is here, right? We have any user, we have our cache, right? This is our cache. We have our DB. So if there is any write request or update or put request, what we do, we make sure that it's in message queue or something like that. We will make a message queue or something. We will store that things in cache, the values which we need to update in the server. Then after we will respond back that it has been updated, but it's not updated, it's in message queue or it's in cache still. We'll pick it using cron job and then we will update the entry in this DB. So that's how read behind cache works. So it improves the write performance, right? Because user will get faster response. So rather write performance will be faster. Now there could be data loss if the cache goes down prior to its content hitting the data store, right? So if cache goes down, for this also we can use master slave architecture, right? We can have some backup cache system, but that depends. The initial disadvantages, there can be a data loss due to cache going down, okay, prior to writing in database. Okay. Now second is what? It is more complex to implement write behind than it is to implement cache aside or write through. So this is complexity is higher because we don't know like what, even if we implement this, right? If we implement this, there can be a scenario that user try to write this and it takes time to write, right? Now there will be a read operation. What if user try to fetch it after writing? So what we can do? We can update that in cache itself, but there can be some complex data, other things we need to fetch from the DB, the master DB. Then it can become complex because there will be some computation or calculations based on the other data that we need to do. And if we do not update this entry, the logic might not work. So the complexity is higher. Okay, so complexity can be higher. So what can be the let me show you the diagram for this as I created. But yeah, this can be user hits cache. Let's suppose this is our cache queues our write request, which I already explained. Okay, so this can be a message queue. Write request. Okay. After queuing this, it will return the response. Return 200 response that it has been successfully wrote. Now what will happen? There will be event processor, which will process our event, and then it will write in DB, right? So it will execute events from MQ, which is message queue. So this will make sure our write operations are faster. This is one way of doing that. Okay. Now let's learn about write through. What is write through? Write through cache. What is write through cache? Let's learn about this. The application uses the cache as the main data store, reading and writing data to it, while the cache is responsible for reading and writing to the database. Okay. So what happens? We have a user, we have our cache, we have our actual DB. Okay. So the responsibility of reading and writing happens on cache. So read and write operations take place on cache. Now writing to the DB is the responsibility of cache. So writing data on DB is responsibility of cache. Okay, this is our user, happy user. Okay, he's happy, he can get read and write faster. After that, our MQ, message queue, or whatever we are trying to share, whatever message queue we use to queue your task, to write the operation, to write the data in DB, that depends. So that will be like a background process, I would say, right? So that depends. Now application, this application adds updates entry in cache. Cache synchronously writes entry to the data store. So it synchronously write it once we have one write operation. If there is one write operation, it will try to write one write in DB for that entry. But one write operation we have here, but it will respond directly to the user that yes, 200 it has been successfully wrote. Now what write through is a slow overall operation. It's a slow operation because you can see, right? As we are doing it synchronously, which means it will take time, right? This is a synchronous process, so it will take time, right? If it was happening asynchronously, it could be time saving process, but it's a slow operation, right? So first disadvantage is it's a slow operation because we are doing it synchronously, right? Due to write operation, but subsequent reads of just written data are fast, but the retrieval is faster, right? Users are generally more tolerant of latency when updating data than reading data, right? So users are tolerant to updating slower than reading slower because read should be faster. Users aren't tolerant over this. What are the disadvantages, right? This is the advantage actually. Now what are disadvantages? What are disadvantages of this using write through? So first disadvantage, when a new node is created due to failure or scaling, the new node will not cache entries until the entry is updated in the database. Cache aside in conjunction with write through can mitigate the issue. Like when a new node is created due to failure or scaling, if we are scaling or we are using master slave architecture, if new node is created, the new node will not cache entries, right? If we have client and if we have one node which stores cache, When we have created another node which is storage, so how this will behave? It won't behave, right? Now most data written through might never be read. Okay, so most data which is written might never be read. So read and write operations which you are storing on cache, it can happen that some data we are writing every data, right, on the cache itself, but there can be a possibility if let's suppose if there can be some, most of the data, 90% or 50% of the data that we write on cache would never be read by the user. That can happen, right? Like profile fetching, how many times do? We don't. We just go to Instagram, we swipe our reels content, most probably once in a day we try to read our profile. So that can be a misuse of cache, right? So that data, that user profile and user content and user photo, video, reels, whatever bio things or highlights, we can store that in DB itself. We should not store it cache because that's a one time thing, right? So that should be there, and or we can store it in, but a bigger companies, I think they need time is the key for them. So saving that time should be the priority. If reels are the priority, then on cache, if there is some bandwidth, then we can use that bandwidth for reels and other things. But yeah, that depends. I'm not sure. What else? Write through is done. Now cache side. What is cache side? Let's learn about cache side. Cache side. Oh my god, my pencil. Hopefully it's recording. Okay, it's recording. What is cache side? The application is responsible for reading and writing from storage. The cache does not interact with the storage directly. The application does the following. Cache side. Okay, we have kept cache side. That's interesting. So we have kept a cache aside. Our application itself, our app itself interacts with the DB. So read and write operations are taken directly from our app. So the application does the following. What it looks for entry in cache, resulting in cache miss. Load entry from the database, add entry to cache, return entry. Okay. So first it looks for entry in cache. If it's a cache miss, what happens? It tries to pull data from DB, and if data is pulled, what will happen? Add entry to cache, and return entry. So that's how it works. Okay. So what is Memcached? That's all about cache side. Now what is Memcached? Okay, let's learn about this. Memcached. I don't use this space. Memcached. What is Memcached? Memory cache is generally used in this manner. Subsequent reads of data added to the cache are faster. Cache side is also referred to as lazy loading. Only requested data is cached. So this cache side means we are not using any strategy or anything on the cache. We are just adding data to the cache depending on what user requests, right? So that's a cache side thing. We do not use any logic. We do not use any strategy to store our cache. The strategies that we introduced earlier, which were write through, write back, write behind and refresh behind, right? So those strategies we don't use. We use just cache side. So memcache is also like a cache side strategy. So it's generally used in this manner. Memcache is also generally used in this manner. What is Memcache? Let me show you. It's a free and open source high performance distributed memory object caching system. So it's like Redis, which we can use to store cache. So it is also used in generally in this manner. Cache side is also referred to as lazy loading. Lazy loading means lazy loading, you might know, right? There are images, or on if you visit any website, if there are multiple images, we try to lazy load it, right? Whenever user request or user comes to certain section, we try to load it at that time, or we try to load it in background, right? So that's what lazy loading means. We try to load it lazily in the background before user requested. So only request data, but the if condition is that this page should be requested by the user. In that case, it will be load. Now only requested data is cached, which avoids filling up the cache. The data isn't requested, right? So that's benefit of that. Now let's learn about strategies. Let's learn. These were strategies. We have learned. We have seen all these strategies, which were. We have seen cache side, we have seen write through cache, we have seen write behind cache, we have seen refresh ahead. Okay, so these are all things we have saw. Now let's learn about types of caching. What is client caching and other things.